Hey guys, everyone, if you want to join, please sit. If not, outside. Thank you. So we're going to change the subject a little bit. We're not going to talk about catastrophic events. We're actually going to talk about the fun, understand a little bit who is going the MEV, is getting the MEV, and when I'm talking about MEV, it's really I'm talking about money. So you think about who's getting the rewards, who's getting the MVP. It's really boiled down to 3 or maybe 4 players. When you think about each player, you want to think about what's their goal. Usually it's 2 things that are trying to maximize, or one of them it's one, and you want to think about the competition. Really the competition is the key. The first, the competition, they're not making a lot of money. So first of all, the searchers. Obviously, the searchers are the one who create the transaction, create the order flow, bundles. They are the one who find the opportunity. They are the one who pay the priority fee. They are the one who bribe. Their goal, basically 2 goals. They are trying to get into the next block. Otherwise, their transaction, their order flow is not going to be valid. And they are trying to keep some of the reward for themselves. Competition is super hard. So if you are a searcher and you have an alpha and you know that you are the only one that can find it, then you're going to keep 90% to yourself because you are not worried. But if on most cases when you don't have the alpha, you end up bidding more than 90% to the next player, which is the builder. So the builders are basically trying to maximize 2 different goals. They are trying to land the next block. Basically, they are trying to make sure that their block will be selected, and they are trying to keep a portion of the reward. Okay, so if they created a block worth 1 ETH, they are trying to maximize the amount of rewards that they can keep to themselves while still winning. So competition in this case, it really depends whether as a builder you have an edge or not. So we'll talk about that. If you have your own private order flow, or if you have some exclusivity and you have some order flow that is paying a lot of priority fee or it's paying a lot of bribe, and you are the only one who's going to have it, you will be able to keep a bigger portion of the reward for yourself. If not, you're going to pass most of the rewards to the next player. So the next player, MEV Relay, they basically have 2 things that they are thinking about or trying. The first one is to relay the block, to increase their win rate, make sure that the proposer is using them in order to relay the block. And the second thing is thinking how can we make money out of it and not make it a public good, and so far they are failing and it's a public good. Okay, so nothing much to talk about the MEV relay. And the next player are the validators or a proposer in each slot. And life is fun, no competition. Every slot it's a single proposer. You don't have to share anything with anyone. You can take everything that a builder is willing to give you, you can keep to yourself. So we're going to talk a little bit about how, yes?
Is it okay if I ask a question?
It depends on the question, if I know the answer.
On that slide, so it says splitting the MEV pie, but actually the relays are the only ones that actually don't earn anything right now. Everyone else earns. Why is that, and is that going to change?
No, to simplify things, I'm thinking about the MEV as a zero-sum game. Okay, so think about the pie of MEV, and everyone in the ecosystem, all the player wants to get a piece. MEV relay simply cannot find a way to get it, and we'll see in the second one. Okay, if MEV relay, in the next slide we're going to see how things have changed in the last year. Where last year, I can tell you, it was all a tech whoever has the best technology won. Today, whoever has the best business team can win. Okay. I can think of scenario how MEV relay are going to start making money if they're all going to make a strike, and we're not gonna relay anything unless we get a portion. They will start winning, but that's not where we are. So let's quickly understand the block life cycle, because that will help us to understand the next few slides. So a searcher uses wallet, DApps, create an order flow, send it either as a private transaction, a bundle, mempool transaction to one or several builders. Builders create their best blocks, not a single block, best blocks. They constantly create more and more blocks, improving the value that they can offer to the validator. They send it to one or many MEV relay. Over here we can see only one, but you can assume there are several MEV relays. And on the right side, a proposer. Every slot, a different proposer will ask the relay for a bid, ask one or several relay for a bid, and will pick the best bid. So let's start with the proposer when we trying to understand how can they make more reward, or how are they making their reward. So let's review the life cycle or the flow from their side. A proposer will issue a get header request. That's the request that they're issuing to one or several relay, asking for the bids. Each relay return the bids. They will select the one that pay them the most, sign it, sign the header, send it back as a request. That request is called get payload. Send the request back to one or several relays, and eventually the block that they selected will add it to the network. So when a year and a half ago, when we released the post-merge, when we released the PBS, this is how things were designed. This is how things should have worked. This is how they worked a year and a half ago. A proposer will issue a get header somewhere immediately after the beginning of the slot. So depending on when the proposer realized that the slot is starting, somewhere between 0 to 200, 300 milliseconds after the beginning of the slot, will issue a get header request. Within a few hundred milliseconds, the proposer will get a reply from all the relays that it's connected. 900 milliseconds was the timeout, so anything after 900 milliseconds was ignored. And get payload, which start the propagation of the block, started immediately as soon as the proposer picked the best block, the best bid. And you basically have 4 seconds to propagate your block in the network, otherwise it's going to be a missed slot. Okay? So that was the design. What are we seeing right now? We are seeing get header that are happening anywhere between 0 to even 3 seconds. Okay? And obviously, get payload, the block propagation, depend on the time of the get header, but get payload might start 3 seconds after the slot if that's the time that the get header So this is where I want to introduce the concept of timing game. So if you are not familiar with timing games, you can see on the top probably the best report or analysis of timing games. So definitely recommend reading it. But timing game as a concept means that the bid selection will be delayed and will happen not as I showed here, until the 900 millisecond after the slot, but it can happen, for example, 2 seconds or 3 seconds after the slot. Now there are 2 ways, or 3 ways that you, or several ways that you can get timing in. The proposer maybe is delaying the get header request. Instead of issuing it on the 0 millisecond after the beginning of the slot, maybe they are waiting and are issuing the get header 2 seconds after the slot. Maybe they are actually asking the relay for the get header at the beginning of the slot, but the relay is the one who is doing the delay. That's also a timing game. The first one is a timing game by the proposer. The second one is a timing game by the relay. That's another concept of a timing game. The proposer will issue a get header request to the relay immediately at the beginning of the slot, but, and we'll see later by when we talk about block cancellation, we'll continue doing that until maybe 2 seconds after the slot, eventually pick the best bids, even if that bid was in the beginning of the first time that it issued the get header, or maybe the third time, and that will be the selected bid. All those are timing. So what do we really see in terms of data? So this is an analysis I did a week ago based on 50,000 slots from our relay, and we can see by average the first time, because remember for each slot there might be several get header from the same proposer. The first time that we see a get header is 411 milliseconds after the slot, but you can see the long tail. Okay, so you can see that there are enough cases where 1.5 seconds after the slot we see the get header. Now that can be, there can be several reasons for that. There can be a reason where the proposer deliberately delaying the request, or maybe the infrastructure is bad. Maybe the proposer is running from the basement somewhere in very far from the nearest relay, and it just takes a long time. So both of them can explain it. Now, for timing game, if you are actually doing a delay, what's the motivation behind it? So here's a graph from the analysis the P2P org did, and it clearly shows that the more that you wait, the higher the reward. Okay, and it can be 10, it can be 15% increase in the reward. And for a validator that is only doing a few blocks a year, to get 10 or 15% more reward, that's huge. Okay, so that's the motivation behind timing. And what's the problem? Why not everyone are doing it? Why you heard in the previous slide that timing game is a concern? The reason is that it increased the chances of a missing slot. So remember that I talked about 4 seconds, your block must be propagated in the network. The more that you wait, you increase the chances of a missed slot. There are 3 things that needs to happen when you select a bid and sign it. The first thing is the MEV reader needs to get it, okay, to get the signed bid. The second thing is the MEV reader needs to validate your sign header. And the last thing, it needs to, the payload, the block itself needs to be propagated in the network. So let's examine all 3 of those. So back to the 50,000 slot analysis. This is the time where our relay receives the get payload. Get payload, I remind you, that's the time that the relay is getting the signed header. 1.7 seconds into the slot. Okay. Average, remember, get header was 411. Get payload by average 1.7. And I'm not that worried about the 1.7, I'm worried about the very long tail there, where sometimes our relay receiving the get payload 3.5 seconds into the slot. That gives only 500 milliseconds for the block to be propagated in the network before the slot will be missed. Okay, so the second thing that we talked about is when the relay receives the get payload, it needs to validate. So over here, I'm going to talk about two different use cases or two different scenarios. The first one is if our relay trusts the validator, and this is a concept that in bloXroute we have of trusted validator. And if we don't know who the validator is, and we can trust it. So if we trust the validator, it basically means that we can ease a little bit the verification and improve the latency. If we don't trust, we need to do a full verification. So when we don't trust, it takes our relay 179 milliseconds by average to validate the payload. And again, I think we can improve it, but it's not the big problem. The big problem is, look on the right side, you can see the 10% of the time it takes 300, 400 milliseconds to validate. That's the big problem. This is where it's likely it's going to increase significantly the chances of missed slot. And this is for trusted validator. Average is, of course, smaller, 167. And you can also see that the 300, 400 millisecond bars are not smaller. But it's still, you need, as a proposer, you need to account for the time that the relay will need to validate your proposal, your payload. So first thing was to get the signed payload. The second thing was to validate. And now let's talk about the last thing, to actually propagate the payload in the network. So with our VDN, it takes about 120, 130 milliseconds from the time the block is being sent into our VDN to reach anywhere in the world using our network, but not everyone, of course, are using our network. So this is an analysis that Yuki from Fangushi Capital is doing together with me on our data. This is the data where bloXroute BDN network, so first time see a block for the first time in the slot. So what you can see here, this is I'm just giving you kind of like a first preview of it, but if you want to actually look at it, wait for the analysis. But you can see, first of all, you can see the shape, and you can see how many times. The 2 billion is basically 2 seconds. This is in nanoseconds. So you can see how many times for the first time, we see a block after 2 seconds, 2.5, 3 seconds. This is the first time that bloXroute network is seeing a block. From there, it still need to be propagated another 150 milliseconds in our network, and from our network needs to go to the validator, and validator still need to attest to it. So you can see on the bottom how it looks like when it's a missed slot. Yes, clearly you can see a little bit of correlation with missed slot. It's the first time that we see a slot is in delay, but to actually see the correlation, let's wait for the analysis. And the other thing that is kind of like surprising, but it is what it is. Obviously, not all missed slot is because of propagation. So 50% of the missed slot, our network didn't even see a block. Okay, so it's, for example, if a proposer had a very bad infrastructure and requests to the relay, the first relay event arrive after the timeout, there will not be any block. Or actually there will be a block created locally. But if, for example, the validator node is down, there's not going to be a block, and so on. So this is an example that 50% of the time, at least our network, did not see a block. Okay, and we have a full presentation by Benjamin on the Validator Gateway, which is a new product, but a new concept where bloXroute is introducing to cut latency for validator and improve the reward. I'm just going to talk briefly about it, but the idea here is that we can bring the relay close to the validator, reduce the latency from the relay to the validator to 0 millisecond, 1 millisecond, 2 millisecond, making sure that without including delay, without doing any timing gap, we can give the validator the best header and make sure that the propagation in the network will actually going to be optimal. Now, why is this needed? Because think about it. If a proposer is very much against timing gap, but a proposer has invested in infrastructure and is locating at the same region as the relay. And that proposer is going to work just with a single relay. So at 0 millisecond, the proposer will issue the get header to the relay. Extremely good infrastructure. MEV relay will reply within 20 milliseconds. So the proposer pick a bit 20 milliseconds after the beginning of the slot, propagate everything within half a second, and lost 10% of the revenue because they are being penalized for because they invested in infrastructure. So this is something that we feel that needs to be changed. If somebody is actually investing in infrastructure, investing in reducing latency, we need to find a way to increase the rewards and not decrease the reward. So that's the Validator Gateway, and there's going to be a section about it. So when we talk about Validator, we're talking actually about two different types of rewards. And I like the zero-sum game that I mentioned earlier, where it's all one big pie. When we talk about the consensus layer reward, this is something that only the proposer can get. So over here, it's just about improving your infrastructure if you want to make more money. Okay? So I'm going to talk here about the biggest problem that validators are facing with regard to consensus layer rewards. And again, the Validator Gateway is a product that I mentioned is solving that. And the problem is when there are forks, validators sometimes are attesting on the wrong head. And if you are attesting on the wrong block, you're basically going to get no reward. So, for example, in this case, that's a real case, of course. Slot 979 in the end. After 979, there was the 980. That's a missed slot. Maybe it was created too late after the 4 seconds. 981 block was pointing to the same header as the 979. And now a validator that needs to attest to 982 need to make a decision between 980 and 981. What will be what the block will be based on? And if they are going to pick the 980, since we know that the 982 one, they are basically not going to get the reward on it. So the way we solved it is, again, using the bloXroute BDN, we introduce a new concept of attestation manager, where nodes around the world using the BDN are reporting on attestation count for every block that they are seeing. That reside within the Validator Gateway that I mentioned is local to the node operator. And then when the customer on the right side are actually validator node, they can issue the request for the Validator Gateway to get the count for every block that they are seeing. With that, they can understand what is the chances for a fork. It can tell you if there is one block or 2 blocks. It can tell you what's the count that we are seeing in the network. And if, for example, you see two blocks, you will be able to know which one to pick. Or if you see one block, but it's a very small number of count, you might want to maybe to delay a little bit and make sure that you are making the right choice. Okay, so that's an example. I'm going to skip on that. The last thing to mention is Dencun and timing game. So not many people talking about it yet, but obviously you know with Dencun we're gonna have blocks. We can expect the block size to be much bigger. We can expect propagation of block to be it's going to take longer, and unless we are making sure that propagation will be optimized, for example, using the bloXroute BDN, or that proposers are taking that into account and not delaying get header and get payload too much, we are going to see an increase in this system. Okay, so that was the first part, talking about the proposer. Let's talk a little bit about the builder. So, to be a successful builders today, you basically need to have 5 things. 2 of them are technical, and the other 2 has nothing to do with your technical ability. Well, the first thing that you need to do is you need to have the technical skill to create better blocks. So that means to take bundles, to take transactions, to order them successfully, to decide which one to include, which one not, in order to create the best block, the one that will have better value than what other competitors are doing. The second thing that gives you the advantage when you're competing with others is if you are not just a builder, but you are also a searcher. So if you have your own private order flow, yourself private order flow, that you know that the other don't have, that's give you a huge advantage, because assuming that you have the same order flow as the other, and you have the same technical skill, as I mentioned in the first point, you're going to create the same block as your competitors. But if you have, in addition, something that they don't have, then you create a better one. The third thing is fast block cancellation. So we'll talk about that in a second. That's very important if you want to compete and you want to make money. So when I say how to win, I'm actually talking about how to make money. And then the last 2 points are, again, has nothing to do with your technical skill. Is how can you get more order flow that other will not have. So that's, for many, it's really a business. Okay, so honestly, if I'm right now going to leave bloXroute and I'm going to create a company that the whole purpose is becoming the #1 builder, I'm telling you, I'm going to have 5 people in the company. 3 of them will be business. Okay, and I'm saying that not as an alpha for you how to do it. I'm saying it because it's better. Okay. Because a year and a half ago, it was exciting to be a builder. If you were a CFI, DeFi builder, it was great. Today, that's not the vision that I had a year and a half ago when I thought about PBS. This has nothing to do with the reason why we separated block building from the proposal. Let's cut some deal, let's pay some money, let's get some order flow that other builder will not have. The second thing is subsidizing. Okay, I don't have the order flow, so I'm willing to pay in order to win. Okay, I will talk about that in a second, but again, that's not something that I want to see staying here for a long time. Okay, so the first thing is how can you create better block? So this is an experiment that we did. We basically took the vanilla open book builder and then we took a sophisticated builder. We gave both builder exactly the same order flow. So all the transaction, all the bundle that both builder received the same. And it was clearly to see that the sophisticated builder created 14% average better block. So that's huge. So investing in a technology that allows you to create better better block is mandatory. Okay, so the other thing about the second thing was if you are a CFI DeFi or you create your own order flow, of course, and there's nothing here I can talk about it. If you don't have that, you don't have it. But let's talk about block cancellation. So that's something that I see a lot that I think it's a mistake by many builders. So we'll talk about that. But the concept is this. Let's say that I'm a CFI DeFi trader that I'm also doing block building. So I have my CFI operation, and I'm seeing a great opportunity with Binance, and I'm decided that I'm going to create a block with a trade of mine that is very expensive for me because I know that I'm going to win some on Binance. So I'm creating a block, and 200 milliseconds later, I'm getting a signal from CFI that the opportunity changed. So now if I want to still win, or more likely if I now don't want to lose, I need to cancel my block. So in order to be a very good builder, you need to have the ability to quickly cancel the block. So what does it mean quickly cancel the block? So look on the top is the builder, the relay in the middle, and the proposer on the bottom. I'm creating block 0, I'm sending it to the relay. Then I'm creating block 1, sending it to the relay, creating block 2, sending it to the relay. I always want to send my latest block as that's my goal. So if the proposer sends the request to the get header request, and the request, you can see the green one arrived after B2 was arrived to the relay is returning B2, and that's exactly what I wanted. So you can see the builder and the relay and the proposer are all in the same region. We can assume no latency. So it's great, I know I'm sending it and the relay will process it immediately. And if the request will arrive after the block time, that will be returned. So that's great. What happens if the builder and the relay are not on the same region? So let's say the builder is in Europe and the relay is in the US. So in this case, you can see there is some delay. So blocks arriving to the relay, 50 millisecond, 35 millisecond delay. So in our case, the proposer is issuing a get header, and you can see this time the get header arrived before block B2. So in this case, block B1 is the block that is being returned, and I lost money. The worst thing that here happened to me is that the relay returned a block that I wanted to cancel, and I did not have the opportunity to cancel. And the reason why is because the latency between the builder and the relay. So many relays, many builders are under the assumption that they should work only with the relay that is local to them, which is a mistake. So they are working basically like the first setup. But let's look on this case as well. So builder and relay are in the same region, as we discussed. But let's assume that the proposer is on a different region. So in this case, proposer maybe is in the US, but the builder is in Europe. The get header arrived to the relay a long time after block B2, and block B2 is being returned. So exactly what I needed, what I wanted. However, that's really not the case. Why is that? Because usually builders, they don't want to miss the opportunity, so they are running the operation in several regions. So the same builder will have a builder in the US, and we'll have a builder in EU, for example. And let's assume now that they are going to submit blocks just to local relay. So the US builder is submitting only to the US relay, and the EU builder only to the EU relay. And now let's see what happens when the proposer is sending the get header. In our case, B1, B2, but also B3 is replacing B2. And let's say that if you are landing, if B2 is the one that is going to select, I'm going to lose money. And it's important to understand that in this case, the value of B3 is lower than the value of B2. Why? Because, as I said, there was a huge opportunity in Binance, and the builder was willing to bribe the validator a lot. But now the opportunity is gone. So the builder is creating B3 with a lower value. Now let's see what happened. The proposer is sending the get header. The get header arriving to the top relay late because it's on a different region, and the relay return block B3, exactly what I needed. So I did not lose the money here. However, let's look on the relay that is on the same region as the proposer. The relay will receive the get header quickly before it receives B3 because of the two region. So the relay will return B2. Now the proposer got two different blocks, B2 and B3. B2 pays a lot more, so it's going to pick B2. So as a builder, I lost money, even that I picked the relay that is on the same region. So that's a mistake that many builders are doing, and they are not realizing it. To solve this problem, it's very simple. You need to invest in an infrastructure that can cut the latency to MEV relay. Whether it's local on the same region or if it's a different region. And I know, by the way, companies that that's what they are doing. We have a good solution for this. Okay, so the last two things I want to talk is about the order flow. I already expressed my concern that if you have a private order flow that other builders have, you have a huge advantage. Okay, and really, what we're seeing today, where some builders are getting it by some kind of off-chain agreement and so on, is not, I think, where we want the Ethereum to go. Okay, so I'm going to stop here, but that's my personal opinion. And the last thing is the subsidizing form. So the more order flow that you have, we said you have a better chance to win. But you will not get order flow unless you win it. So in order for you to win, you need either to get order flow, but you're not getting it, or you are willing to say, I'm going to lose money in the beginning, and I'm going to buy my block space. I'm going to subsidize. And what we are seeing, we are seeing this is a strategy by many builders, especially the small builders that don't have the advantage. They are doing this strategy of let's lose money, let's subsidize, let's gain 0.5%, 1%, 2% of the block space. Let's make a name for ourselves. So searcher will start sending us a bundle, and then we can start subsidizing because then we're going to get the order flow. This is great, but it's working only in theory. Because it takes a long time for whoever is sending the transaction to modify their application and add more builder. People now are not they already accepted that strategy, and they are saying, well, I don't know who that builder is. It now have 1%, but in 1 week they will not have 1%. And sending them my transaction, if I don't know who that builder is a risk for me, because that builder can be malicious, can front run me, can do some betting with my bundle. So I'm seeing more and more of builders that are subsidizing for 2 weeks, stop subsidizing, 3 weeks not winning anything, trying again for 1 week, losing money, stop subsidizing. Again, not where we wanted to be a year and a half. Questions? How am I doing with the time? All right, cool. Thank you, guys. Yes?
One question. Can you go back to the slide where you showed the 14% improvement in the block?
Yeah.
So this is a comparison of what would be a simple block, right? Compared to
This is a comparison of the Flashbot open source builder versus a strong tech builder that has a better algorithm to arrange blocks.
Got it. So still both relayed blocks, both built by builders. It's not a comparison to a vanilla block built without a relay, correct?
Yeah, vanilla block without relay is 300% down.
Yeah.
Cool. Thank you, guys.